Well, hello there, and welcome to Unit 9. I know you're excited to do this over break, so let's begin. So today we're reviewing the laws of exponents. So you should remember some of the laws of exponents, but the first thing that you do have to remember is the parts of a power. Okay, so the parts of a power, so this is a power. Bam. This is a power, and you have to know the two parts. So x here, this x is the base, called the base, and 2, hopefully you know that, that's the exponent. So you got a base and an exponent of a power. So as long as you know those two things, the rest should come quite simply. Okay, so the first rule, and as it says here, there are only 3 rules. That's it, just 3. Just know them. You don't have to love them, but I know you will by the end. Okay, so first rule is when you multiply bases, so remember x and x, those are the bases, so you're multiplying the same base, you add the exponents. So this says it in math, and this says it in English. So for example here, when you multiply these two things together, this times this, you multiply the numbers. Hopefully, it's just numbers always multiply the same, so don't try to change that around. Okay, so multiply the numbers and look at the bases. X and x are the same base, so you add the 2 and the 4. Y and y are the same, so you add the 1 and the 3. That's it. Okay, just so you realize y, just give me that, okay, just for a second. X squared is x times x. X to the 4th is 4 of them. So you put them all together. I have 6. There are now 6. Okay, look at the y's. There's 1 y sitting there. Here there's 3. Put them together. I have 4. Super exciting. All right, next. So here we're dividing. Dividing has a clue inside it. This little sign right here. This little line. When you're dividing, you subtract. So anytime you think dividing, you subtract the exponents. So remember, when you're dividing bases, same base, add the exponents. All right, again, math and English. So here, numbers dividing, numbers divide. So 14 divided by 2 is 7. And then x to the 6 divided by x to the 6. 6 minus 6 is 0. Or you guys know, but those just go away. That's just nothing. I don't know why I put anything there. And then the y to the 3rd has nothing. Nothing down here. No y, so y to the 3rd stays in the top. And that's it. Okay, this one, the third and final rule, is power to a power. So that means, see how I have x to the a here? That's the base, and that's the exponent. So anytime you have an exponent to a whole term, you multiply the exponents. Okay? So here, you have to know what the exponents are. So remember, it's always the exponents get multiplied, nothing else, exponents. So 3 has a 1 on it, and y has a 1 on it. So 1 times 4, 4. 5 times 4, 20. 1 times 4, 4. Should figure out what 3 to the 4th is. 3 to the, whatever, it's 81. So it's x to the 20, y to the 4th. Now you could do this one on your own, like we did a couple times back, and you can write this out 4 times. So this exponent means that this is the base, and we write it 4 times. Anytime you do an exponent, that means you write it that many times. Seems like a bit of an excessive amount of work for me. Oh, I don't know what that was. That should have been y to the 1st here. I don't know what the hell that is. Sorry. Okay, And then you could do like multiply 3 times 3 times 3 times 3, get 81, add 5, 5, 5, and 5, and get 20, and then 1, 1, 1, and 1, and get 4. However, power to a power, shortcut, and it's only the third rule. But if you want to do only 2 rules with multiplying and adding, you could do it that way. So, you know, thought I'd give you a little gift on Christmas, or excuse me, your gift-giving holiday. Here's some super fun examples. Super fun. All right, you got to decide which rule you're going to follow here. Sometimes it's more than one. In this case, there's only one. These are your bases. You're multiplying them right there. Multiply. So when you multiply bases, you add the exponents. So in this case, this is the exponent. So it doesn't stay nice numbers. This is algebra 2. We take it up a notch. So we add the exponents. 2x plus 3 is one exponent. 4x minus 7 is another. Let's just add them. 6x minus 4. That's the exponent. The base is still x. So it's x to the 6x minus 4. As simple as that. It looks complicated, but it's not. All right, the next example. Here we're dividing. This is a dividing problem. This line here means divide. So remember, dividing gives you a clue. Subtract exponents. So you just have to be careful. You remember how to subtract. Remember, it's the top one. Oh, excuse me. It's the top one minus the bottom one. So I'm subtracting this. So remember, it's keep, change, change. So I minus, change the c to a minus c, and the negative 2 to a positive 2. So when I subtract those two, I wind up getting 1c, or c, plus 6 as the exponent. So it's x to the c plus 6. This next one is got a big exponent on the top there, so this is going to involve power to a power. But you got to be careful. That 2 goes to everything, so everything needs an exponent. So 4 gets an exponent, 3 gets an exponent. X's exponent is 3a, and y's exponent is 4c. So everything has an exponent now. Now just multiply. So 4's exponent is 1. So 1 times 2 is 2. 3a times 2 is 6a. 1 times 2 is 2. And 4c times 2 is 8c. Please don't make up new rules. Okay? When you multiply, you multiply. 2 times 4c, 8c. Done. As long as I didn't mess up somewhere else. But no, that looks good. And then you should do the math if you can. So 4 squared is 16. X to the 6a. 3 squared is 9. Y to the 8c. Nothing is the same. There's no like bases. 16 and 9 can't be reduced. So that's it. Next. All right, try these out. These involved a little bit more. Fast forward me, or you know what? I'll pause. I'll give it a pause, and then you do these and see how you do. A little more involved in these, but it's still good to try. All right, here are the answers. Quick word on the ones with a number for a base. One of the most common things for people to do is try and change that base, but it's not possible. All right, so if, like, for example, if I have 3 squared times 3 cubed, 3 squared is 3 times 3. 3 cubed is 3 times 3 times 3. That's still, there's 1, 2, 3, 4, 5 threes, so that's going to be 3 to the 5th. Okay, that 3 does not change. Please do not do that. Okay, so 3 to the 4 plus a, so multiplying bases. So you're adding the exponents, the 4 and the a. Here you did power to power first. Put the 1 on the 2, so it's 2 to the 5th, x to the 5th. And then you subtracted your exponents. There's other ways to do that, but as long as you wound up with 16x squared, it's all good. And then here you divided, so you subtracted the exponents. Again, the 10 stays a 10. Okay? Next, 0 as an exponent. Why is anything to the 0 power 1? I'm glad you asked. Very inquisitive during vacation. It's nice to see. Well, you know that anything divided by itself is 1. Hopefully you know that since x to the 5th divided by x to the 5th is 1 regardless. But if you follow our exponent rules, you subtract exponents. So it's 5 minus 5, or x to the 0. So anytime you divide something like that, you subtract the exponents, and x to the 0 is 1, because that's what that is. All right, the hardest part of this is just deciding what is being raised to the 0 power. So you have to make sure you know what the base is for each of these exponents. The base is just what it's touching, nothing else, just what it's touching. So here, the 0 is touching just the 7, so it's 1. If you look here, 0 is touching just the 7. So this one's answer is, you guessed it, -1. Put it in your calculator. I know you don't believe me, but just do it. It's the way it is. This is +1. Okay, so just be careful of that. The -1 is sometimes the hardest one to see, but that 0 is just touching the 7. It's not touching that negative. So make sure you see that when you're doing these. This one right here, this is the base here. The whole thing, 2x, so all of this becomes 1. Moving on. Here, the base on that 0, what is the base? The base is just the x. So it becomes 2 times 1, or 2. So you have to be very careful. Make sure you realize what is that exponent going to, or what is the base for the exponent, because that's the only thing that gets to be 1. Okay? Moving on. This is, blah, blah. Here we go. The only thing being raised to the 0 power is that x minus 3. That's 1, so it's 5 times 1, or 5. And this one here, the whole thing is being raised to the 0 power. So that is just 1. Another way to write the base is a fraction, negative exponents. All right, doing this the old-fashioned way. When you divide, you subtract your exponents. We know that, but I'm going to do it this way first. Okay, so x to the 3rd has 3 x's, x to the 5th 5 x's. Each one that's the matches gets crossed out. So we got nothing left on the top, which is a 1, and 2 x's left on the bottom, so that's x squared. So this answer here is x squared, but if I follow my exponent rules, I do 3 minus 5, or x to the -2. So x to the -2 is the same as 1 over x squared. So that's all it is. It's a way to write the base, x, as a fraction. It's a fraction now here. See? We love fractions. I know you do. I can tell. I can see it in your face. All right, so negative exponents simply mean the base, remember the base is your x in this case, is in the wrong place. So what I mean by the wrong place, there are 2 parts to every fraction. You've got the top and you've got the bottom. In this one right here, x to the -5th power is in the top, and there's nothing in the bottom, so it's a 1. So if I want to write this as a positive exponent, that means that the base, that x, is in the wrong place, that -5. So all I do now is I take this x to the -5th and I move it to the bottom. When I do that, it now is in the right place, so it's positive. Now we can't just leave it looking like that, because that's not really math, so it is still a fraction. The 1 did not jump to the top there. That didn't happen, but that, you need the 1 as a placeholder. All right, what's most important for you is to ask yourself, what is the exponent going to? What is the base? So in this case, what is the base of this here? So the -3 here, what is it going to? Is it going to the x, or is it going to the 2x? right? We talked about this a little with the 0 exponent. Well, in this case, it's just going to the x, because that's the only thing it's touching. In this one, the -3 is touching the parentheses, which is grouping the 2 and the x together. So in this case, 2x is the base. So that's one of the things you have to realize when you're moving exponents, or, when you're moving bases because of negative exponents, and anytime you're working with exponents, you have to take that into account. So most of our time we do want positive exponents. So to make it positive, when it's negative, you move only the base that's negative and make it positive when you move it. So move it, if it's in the top, put it in the bottom to the top. And if it's positive, don't do anything, just leave it. Follow exponent rules if you have to. And we'll try the most funnest problems we have. I'm good. English is good for me. All right, here we go. So you need fractions here because that negative exponent means a fraction is involved. What is the base for that -6? A is the base for that -6. So to make it a positive exponent, I take that -6 and the A, I move it down, and the 6 becomes positive. Good? So the next one. It's a fraction, so we got to deal with that. Okay. What is that -8 going to? What is the base of it? Is the -5y, or is it just the 5y? Or what? You tell me. Good, good. It is just the y. Just the y. So the y is the only thing that moves. The -5 stays where it is. And the -8 is going only to the y, so the y moves down. And when it moves to the right place, it's positive and happy, like you are right now on vacation. And me is for sure. Okay, this one. Try it out for yourself if you need to. I'm going to erase that because I'm not too bright. So it's in the wrong place. It's on the bottom, so we move it to the top. You can put a 1 at the bottom, but you know what? You don't even need it. It moves to the top. And x to the 7th is the same as x to the 7th over 1, so you're good. Okay, you can try these if you want on your own, but I'm going to do these out because I am. So these we got to simplify. So follow whatever rules of exponents you have. See, look, this is a y and a y. So we need to follow our rules of exponents. So this is dividing. When you divide, you subtract exponents, but you divide numbers. So these are your numbers, 4 and 2. Divide 4 and 2, we get 2. Okay, and whenever you do the subtraction here, so these are the same bases. So here we're subtracting exponents. Whenever you do subtraction, the answer goes in the top. Okay, so I'm going to do -3 minus a -1. So we're dividing bases, so we're subtracting the exponents. -3 minus a -1 is a -2. So that is the exponent on the y, and it goes in the top, like I said. However, I do want to write this with positive exponents because that's what the directions say. So y to the -2 moves. The 2 stays in the same place, but the y goes to the bottom, and the 2 becomes positive, the positive exponent. Super fun. All right, here. Now you can deal with the negatives first, but I personally don't like to. I like to deal with the powers or the exponent rules first. So I'm going to put a 1 on that x, and since this is a power to a power, I multiply the exponents. So an x to the -1, y to the -5th, z to the +2. Remember, I'm multiplying, I'm distributing technically, and I'm multiplying those exponents. All right, now I move them. Okay, the only ones that move are the negative ones. So the z is going to say where it is. So z squared stays on the top. These two are going to move, and their exponents become positive. If you want to leave that 1 there, that's good. You go crazy. All right, this one. Again, I like to deal with the exponents first, the exponent rules. So I'm going to deal with this power to a power situation here. multiply that through first. Notice this only that negative 2 is only going to that. It's not going to the bottom ones. Not. All right, so don't. So those just kind of stay the same there for now. So it's x to the negative 10, y to the positive 8s, and then x to the negative 4, y to the negative 2. Now we subtract our exponents. When you do the subtraction, the answer is going to wind up in the top. So it's negative 10 minus a negative 4. There's an extra negative in there, so make sure you're changing the signs. So it's x to the negative 6, and 8 minus a negative 2. 8 minus a negative 2 is a 10. Just like me. Okay, so then we want to get this, we don't want this to be a negative 6. Y to the 10th is positive, so it stays where it is. X to the negative 6th is negative, so that moves to the bottom. Done. Have a good rest of break. Enjoy.